I've worked in, I'll call it technology space for a long time, originally starting with IBM as a systems engineer. I've been an IT director for manufacturing businesses, including one that manufactured automotive parts, pistons, valves, timing rings, stuff like that. So I've worked in that space for a long time. I had the opportunity to shift over to a software technology company, OTI, in the early 90s. We built really what was a distributed microservices platform for developers, worked on that. So it was an intro not only to microservices architecture before it was popular, but also into Agile before it was, in a sense, defined well. We were using Agile delivery for the products and so on. From there, I worked at Fidelity for 5 years on financial systems as the director of infrastructure services and architecture, Citizens Bank as well, and then had a chance to do a big data project as a lead data architect, architecting a data warehouse for Apple customer care, which is actually interesting. So that presented a lot of data challenges initially. DMX is Dealer Market Exchange, and I was a consultant managing first the product for the website for them, and then second, they tried to expand into a lot of different technologies, and they said, okay, we need a focus for this. They said, let's create a Foundry, and since you're technology oriented, we'll make you the Foundry director. So I was directing or running, if you will, the Foundry to look at new technologies. And of the ones I looked at, the biggest one was blockchain. That was the first thing to focus on. So we were looking at AI, but really didn't do a lot with AI in the time I was working on it. Bigger thing is we did a lot with things like cloud analytics, real-time dashboards and that kind of stuff for dealers, which made sense. But DMX itself, Dealer Market Exchange, what they were doing, they had a couple of different products putting out. The primary one was an online automotive marketplace where dealers could buy and sell vehicles with auctions online and all that stuff. So there's quite a bit there, which involved payment systems and everything else. And we integrated to a lot of different data sources with APIs as well. So it's I'll call it highly integrated. There are probably almost 20 different APIs we connected into real time to pull data into the platform. Everything from government data sources to private data sources, OEM builds for vehicles, all that stuff came in to us. In addition to that, they created two different products. They were all mobile phone based. One was an appraisal product and the other was a certified pre-owned vehicle inspection product. And both of those actually wound up going to production. The marketplace is not in production at this point for sure. But the other two products, the mobile appraisal and the certified pre-owned vehicle, both of those are in production. Anyway, so that's the work.
Quick thing, like the screen is working now.
Okay, great.
So you can use the slides. You just need to tell me like when to click.
Okay. So again, I said I was a contract director for DMX. And so my actual company is Sky Web Team, but it's DMX that we're going to talk about as a start. And then we're also going to talk today about Mobile Open Blockchain Initiative for connected vehicles in the marketplace and so on. So you can go to the next slide. We'll hit the agenda really quickly. In there, we've got just a quick overview of the marketplace. There's a lot of content here. I'm not going to read all the slides. I'll selectively focus on some of those as we go. And you'll have the handout for reference later. But we'll talk about the marketplace a little bit. We'll level set on some basic blockchain concepts. We'll talk about Hyperledger enterprise blockchain concepts are a little bit different than basic blockchain like Bitcoin or Ethereum. And then talk about VinBlock, which is something I created as an original vehicle identity chain using Hyperledger Fabric. And then focus really on Mobi and what they're trying to do as this consortium of all the auto industry participants trying to figure out how do we leverage blockchain technology with all of the other things that are going on with connected vehicles. And so as part of Mobi, I work on two different Mobi teams there, vehicle identity and the connected data marketplace. But we bring in a lot of the vendors that you have here today have presented at Mobi to give us input on their ideas on how to put together solutions in different areas, whether it's digital wallets for the car, payment systems, parking, and so on. So a lot of different input from a lot of technology companies. And as you're aware, in the connected mobility space, MOBI is, I'll call it, one standards body, if you will. That's an organization of member companies, but there's a lot of other standard bodies that apply as well. We've got W3C, Digital Identity Foundation, IEEE, all kinds of different organizations that are standards-based as well. And if you're working in standards area, you want to be able to leverage those standards that have already been defined, and especially ones that are in use in vehicles today. That said, if you can go to the next slide, please. Yeah, so again, the marketplace, you can read that. It's basically just, that was back in 2018 with the pandemic. There's two things. One, the major trend, certainly in the US, and I can't speak for the whole world, but in the US, in a sense, the new vehicle sales were predicted to decline anyway. In 2020, the pandemic has only made that, of course, much worse. Although there's some recovery now, certainly it's been a tough marketplace to work in for new vehicle sales. And especially with fleets, the leasing fleets now are cutting back on their purchases as well. So that's had an impact on OEMs everywhere. So that said, if you can go to the next slide. All right, let me flip. Apologize, catch up. So if you look, there's some key concerns in mobility. We talked about some of those, the new car sales trends. Everything is trending down in the short term anyway. We also have changes in vehicle types with electronic vehicles and so on, changes in ownership models and so on, with ride sharing subscriptions now having gone up. Another area that's a big impact, of course, is privacy regulations by jurisdiction. So GDPR in Europe, California Consumer Protection Act in the US, and other regulations that apply and affect vehicle usage as well. Supply and demand is now, especially with urban areas, you're getting a coordination of supply and demand for transportation across all different forms. So whether it be London or New York or wherever, they're in a sense trying to tax vehicles in certain areas of the city to reduce density there on the vehicle side, and at the same time we coordinate bus and rail service as well. And of course, there's been changes in both supply chains and technology for supply chains, as well as trade regulations. As far as technology goes, the software-defined vehicle, the concept of the digital twin, lots of manufacturers have been using that to build and test components. We have decentralized smart vehicle subsystems now on all the vehicles. Again, some of the participants here, ZF Industries and other ones, have been leading the way in that. We have over-the-air vehicle software updates as a way to maintain software on the vehicle. Certainly that's worked for at least my infotainment systems on a Honda. 5G vehicle to connectivity to outside sources or external sources. Challenge of 5G, of course, is it's rolling out. The other challenge is that its range is somewhat limited, but it's certainly in urban areas and other areas where there's more dense coverage, 5G should be effective. But it does provide much higher bandwidth for off-vehicle applications. Related technologies, I'm not going to go into those except to say that, yes, AI, Internet of Things or device integration, analytics, cloud automation, all that complements blockchain as a technology. Autonomous driving levels, you have companies here focused on that, but really the levels are defined 0 to 5, and different companies and different vehicles at this point have different levels of, if you will, driver assistance or driver automation. So that's the marketplace. Next slide we'll talk about blockchain basic concepts. So if we go to the next slide, on blockchain features for DLT, there's 5 attributes to a blockchain that matter to me. I don't want to go into too much detail, but I'll say a distributed ledger technology or blockchain has basically a peer network of organizations that are hosting copies of a shared ledger in sync using smart contracts. So if you look at the diagram on the right, there's 5 organizations in blue down there that are connected on the network real time. And they each have their own copy of a immutable shared ledger, as you can see. So one of those is exploded at the top, and a ledger is made up a series of blocks of transactions that are hashed together in sequence. and each of the blocks contains one or more transactions. And the key to it is when you're writing onto a blockchain on a shared ledger, two things. One, you use a smart contract, which is a secured program that all nodes on the network or all hosts on the network have a copy of the same smart contract. So they're going to be pushing the same updates or writes onto the network. And the other issue is when you write onto the network, based on network policy for the blockchain, all the organizations are required to, in a sense, come to some form of consensus that the transaction is valid. So if they don't agree, don't meet what I call consensus requirements, then the transaction is rejected. So that prevents certain levels of fraud on a network that you don't get when you have a single organization writing to a network or to a database. And then, of course, you have governance services to manage the whole network based on the type of blockchain it is. So if I go to the next slide, I won't talk about what's detail here, except to say, look at the diagram in the bottom of the smart contract. You can see on the left, we have an application. The application runs under some sort of an identity, and that would typical, but then that'll call onto the blockchain a smart contract that's deployed on the blockchain you see there. That smart contract writes the ledger, and when the consensus is complete across the entire network, you get back an acknowledgement that the transaction was finalized as an event. So the applications can automatically react to the event that the transaction has been completed, and that can automate workflows. That said, if we look at a traditional network that I worked on at Fidelity, when we integrated with our partners, internal and external, it looked a lot like the next diagram, which is the current business network. Here you can see that all the organizations are connected on a point-to-point model, and we all have our own separate systems, our own separate databases, and our own separate interfaces. In many cases, we have intermediaries to pass data around as well. And so that network has all kinds of challenges, delays, errors, rework, potential in there, as well as higher audit costs, operational costs, and some inefficiencies, and even trust issues as well. If we go to the blockchain diagram on the next slide, you'll see I call it a blockchain value network. What's different, as you can see, is everybody's linked onto the same blockchain. And even though the participants have different roles, they all have access to the same distributed ledger, and they run the same smart contracts on the ledger as well. And that has some big impacts to make the whole thing a lot more efficient. That said, one important concept of a blockchain that I find a lot of people don't get is they've assumed that every organization on a blockchain network is hosting the network, and well, that's not true. So like a lot of other networks, you can see there's what I call a physical view in this diagram in the right that shows a physical view at the bottom and a logical view of a network at the top. In the physical view, I show that I've got a virtual cloud that has two physical clouds. Maybe that's AWS and IBM as an example. And within that, I've got three hosting organizations for this simple little blockchain I created. And if you look at, so those boxes in gray at the bottom are hosting organizations. If you look at the logical view, the hosting organizations provide what I call membership services in the logical diagram in that green circle at the top. For everybody else on the network. So you can see there's other organizations on the network and other even individuals connected to the network who aren't hosting anything, but they're participating equally in the network. And that's the concept, is that in a blockchain network, participants by role, in a sense, have equal responsibilities, if you will. And that the hosting organizations will provide membership services as well. So it's not a one-to-one that every organization has its own hosting of as part of the blockchain. So it depends upon the blockchain how that gets set up. So next thing we'll take a look at, let's talk about enterprise blockchain concepts. I focused on Hyperledger Fabric for a couple of reasons, but that was the one we started with. It was the one that's most widely used in production today, but there's certainly other blockchains to look at as well, depending upon your use case. So if we move on to, I'll call it blockchain platform choices on that slide, Forbes 50 produces an article every year. Michael Del Castillo and Matt Schifrin do this great job going out, and they look at the largest blockchain implementations that have been done around the world, and they, in a sense, analyze what were the problems you were hoping to solve with blockchain, what was the way you solved it, and what were the impacts from that. I did some analysis on the Forbes 50 for 2020 just to look at what platforms they were running. And I could see in the diagram here that Hyperledger Fabric is the #1 platform that the larger enterprises were using. Second, though, is the public blockchain Ethereum. So the difference is Fabric is a private permission blockchain. You have to become a member to get access to a Fabric blockchain, and there's many of those set up. With Ethereum, you have a single public blockchain in theory that is normally open access. The difference is Ethereum also can run in a private model as well, but it's typically run just in a public model for the most part, for most applications. Of course, this thing does show Bitcoin. Some of the Forbes 50 were using Bitcoin, but that's dedicated just to the Bitcoin asset. It's not I'll call it a normal blockchain that supports, I'll call it true applications, if you will, other than a cryptocurrency. And then Corda on that slide was #3 in terms of usage. And Corda is another type of blockchain that's focused mostly on financial services. So that said, those are the platforms. I won't read all of this, but this slide actually was, I'll call it, very useful for analyzing what do you get from a blockchain in terms of value. So if you look at it on the left, I have features that Hyperledger Fabric provides, and on the right, what are the impacts? So briefly, it's a different type of distributed ledger. You get shared real-time data access. It's the impact. On the left, again, if users have digital identities to access, that means they're trusted, secured identities for users. They're not just a simple user ID and a password. They actually have digital certificates associated with them that can be revoked and so on, granted privileges and everything else. Transactions are signed by users, which means you get a proof who created a transaction on a blockchain. The transactions are endorsed by the network, which means you have proof that the transactions have been approved, not one organization posted them. Transactions are hashed in sequence, which means they occurred at a set time. Transactions are write-only, proof that transactions cannot be changed, and so on. So there's a lot of features there on the left, the impacts on the right. The one thing I'll call out on the bottom that's common now is focusing on interoperability. There's, in a sense, not going to be one blockchain platform that wins. The most important thing is figuring out how different types of blockchains can interact. And there's a project called Hyperledger Cactus that's integrating right now Fabric, Besu, which is an Ethereum client, and the Corda blockchain to show that they can, in a sense, have smart contracts that can read and write between blockchains as well, which is very important. So that said, next slide talks about private data. So while everything is shared on the blockchain, in a sense, everybody has a copy of it, not everybody can see all the data. So typically, if you think about company A and B wanting to share data on a blockchain, company A buys or orders a part from company B, they may want that whole transaction to be private. So they don't want to share the price, how much was purchased, or what the part was. So that's called private data. So if you make data private on a blockchain like Hyperledger Fabric or some of the other platforms, you can see in this diagram on private data that organization 1 can see all of the data because they're buying a part from maybe organization 3. So they can see what they call the channel information about a transaction, but below that, they have access to all the data. If you have organization 2, which wasn't part of the transaction and the data is private, you can see organization 2 still sees a transaction occurred, but they have no idea what the details of that data are. So in a sense, just like traditional systems today that need to have data privacy, we can do that on a blockchain as well. As far as what a stack of software looks like, I won't spend too much time, but just to say this is a vertical stack. At the bottom, you have different cloud platforms connecting with network services. At the next layer, you have virtualization containers holding applications, and within that, you can run something like a Fabric blockchain in orange. You can see the difference with Fabric is we have a blockchain runtime on the left with smart contracts, distributed ledgers, system code, and so on. Other blockchains are going to look like that. What's different is Fabric also offers optionally what they call membership services provider built in, which other blockchains typically don't have that to that degree. So you get certificate authorities and managements inside of Fabric by default if you want it, and a membership services provider as well. But also a lot of companies are going to use outside external systems for certificate and identity management as well. At the top, of course, you have client applications, data, and services. And then you have integration APIs throughout the entire stack and operations tools. So that's the conceptual blockchain software stack.